All right, today we are working through some applications, all the things we've studied with piecewise functions and quadratics and pulling in linear. We're going to try and use them to help us do some applications today. So the goal today is that you can interpret the information given and then build functions or representations of functions to represent them, or use quadratic methods and techniques that we've practiced to solve. So I'm going to break this up into 3 videos. This one's going to cover the piecewise portion. So I'm just going to do an example of like a piecewise function, maybe 2 of them, and then we'll move to a different type in the other video. So first of all, work must be shown to receive credit. So make sure that you're showing work on each of these. It's not just about the answer, but interpreting through this. So the first one, let's talk about piecewise functions. So this is a great example of kind of 2 different like business plans maybe you'd see at a bakery 1 and a bakery 2, and we're going to talk about how these are similar and how they're different. It says 2 different bakeries have the following pricing for large orders of cupcakes. Bakery 1, if a customer orders less than 30 cupcakes, okay, less than, and I like to highlight things as I go through, especially the mathy words that I might need. So less than 30, right? The cupcakes cost $2.50 each. So if we order 20 cupcakes, they're just $2.50 each. If a customer orders anywhere from 30 to 100 cupcakes, the cupcakes are $2 each. If a customer orders more than, so remember more than 100, then the cost is $1.75. So just read through it, kind of interpret. You may even want to try this out before you watch the video, see if you can make sense of it. Bakery 2, so the first 100 cupcakes, okay, it just says the first 100 of any order are going to cost $2. Each of the next 150, so that would mean if we order more than 100 but less than 250, they're going to be $1.75 each. And in each cupcake ordered in excess of 250 is going to be $1.25. Okay, so there's our information. Let's see if we can interpret this. So if Anna's mom needs to purchase 60 cupcakes for her Halloween party, determine what her cost would be if she orders from Bakery 1. Then determine the cost if she orders from Bakery 2. So Bakery 1, if we're just looking up at this information, she's going to order 60 cupcakes. So less than 30 won't apply. 60 is going to be somewhere between 30 to 100. So she's going to have to pay $2 each for her cupcakes. So if I was writing this out and calculating it, that would be $2 for each of the 60 cupcakes. And if we multiply that, looks like she's going to have to pay $120 for those cupcakes. Bakery 2, again, if we look up at its information, the first 100 cupcakes of any order are $2. So again, if she orders 60, that falls in that first domain, and they're going to be $2 each. So this is going to look very similar. She's going to pay $2 for those 60 cupcakes. So because of the number of cupcakes there, that's actually going to be an equal deal. Now notice if we change the amount, so on B it says if Darren needs to order 170 cupcakes for his work luncheon, okay, so we're looking at 170 here, which company provides him the better deal? Provide mathematical evidence to back your decision. So let's once again look at each bakery separately. So let's look at Bakery 1. If we look at Bakery 1 and he's going to order 170 cupcakes, that's definitely not less than 30, definitely not between 30 and 100. So he's going to order more than 100 cupcakes. So they're actually going to be $1.75 each. So we're going to take $1.75. We'll multiply it by 170 cupcakes. And when we do that, we end up with $297.50. So that would cost him just under $300 for those cupcakes. Then if we look at Bakery 2, we'll notice how these are a little bit different. So at Bakery 2, the first 100 cupcakes of any order cost $2. So he's going to order 170, but the first 100 are going to be $2 each. So I'm going to write this out so we can kind of see that. The first 100, no matter what, are going to be $2 each. Then the next number of cupcakes, and in this case it looks like that would be 70 more. The next section of cupcakes from Bakery 2 can be $1.75 each. So now $1.75 for the other 70 cupcakes. So notice we've accounted for 170 cupcakes. They're just different prices, so we've included the prices for each piece. If we simplify that and add that together, we end up with $322 total and 50 cents. So you'll notice if we were comparing these, I'm going to get a different color here. If I'm comparing these, it's definitely Bakery 1 is the better deal, right? Bakery 1 is a lower cost. So we would state that Bakery 1 is the better option, right? For at least cost. I have no idea what they taste like, as it is $25 less. So something along the lines where we're providing some evidence there and then making a conclusion. Now we can write a piecewise function to represent this, and the reason we would use a piecewise is the price changes, right, based on the number of cupcakes you order. So that would be like 3 distinct and different domains or pieces. So let's again kind of spread this out. Let's do Bakery 1 first. So Bakery 1, let's just call this C of X. And we know there's going to be 3 pieces. It's $2.50 each, so that would be like $2.50. I'm going to write 50 just so it makes sense, times the number of cupcakes you buy. If you order, again, less than 30. So that would be when X is less than 30. Now, the lowest amount you can order is 0, so I'll include a cap at 0, and we'll say if it's between 0 up to 30. Then if we order anywhere from 30, so I'm going to put this right here, if we order anywhere from 30 to 100 cupcakes, anywhere in between there, your cost is going to be $2 per cupcake. And if we order more than 100, right, that was the last one, so greater than 100, now you only have to pay $1.75 per cupcake. So this one's pretty straightforward. Every domain, it just changes the rate of change there. When we look at Bakery 2, this one's a little bit more complex, although it starts out about the same, kind of like Anna's mom had the same price for those 60 cupcakes. So if you look at the first one, the first 100 cupcakes of any order are $2. So these are just $2 per cupcake for the first 100. So anywhere from 0 up to 100. Okay. Now the next 150 cupcakes, so from 100 to 250, they are, and I'm going to write that over here, so if I order anywhere from 100 up to 250, they're going to cost $1.75 each. Now remember that the first 100 cupcakes of any order are $2, so you have to make sure that you account for the first 100 being $2. So just like we did here with Bakery 2, we would say 2 times 100 plus 175 times all the rest of them. So essentially the way we would write that, and I'm going to write it out on this one, I'll show you how to simplify it on another one. But essentially here we would say 2 times 100, because they were always going to order in this domain between 100 and 250. And then we would say plus, you're going to pay $1.75 for the rest of them. Now to write the rest of them mathematically, we would say however many you're going to order minus the 100 that you already counted right here for $2. So again, normally we would distribute this and simplify and then write our final function right there, but let's just write it out so we have that example. Now if you order more than 250, so where X is greater than 250, then again you still had to pay $100 for those first, or sorry, $2 each for those first 100. Plus, you're going to have to pay $1.75 for the next 150 cupcakes you order. Okay. Plus, now you're down to the $1.25 per cupcake, and that's for the rest of them. I didn't leave myself a lot of room. But the rest of them, again, would be X minus the $2.50 that we already ordered or accounted for in this 100 and this 150. So this would give us a total cost function there. So notice, depending on how we're interpreting the situation, our piecewise functions can look a little bit different. So wording is really important. We're going to look at one more piecewise, just as an example. And I've given you a couple piecewise functions as well on the partial key. So if you look at, let's say the next one, this has a rental home on Airbnb rents for $100 a night for the first 3 nights. So if you stay 3 nights, you're going to be paying $100 for each of those nights. Then $90 for the next 3. And then each remaining night beyond that is going to be $80. The total cost T of a function of the number of nights X that a guest stays. Write a piecewise function. So we're going to have T of X here. And again, it looks like we're going to have kind of the 3 different pieces. So $100 per night, that's just the rate of 100, right, times X. However many nights I stay, I pay $100. That's only the case if we stay anywhere from 0 to 3 nights. If I stay more than that, suddenly it's $90 a night. Now remember, again, if we're going to stay anywhere from more than 3, you could put a 4 there and include it, up to 6, right? So the next 3 nights. And I'm going to write it over here so that we can simplify the function and then write the final function in our piecewise. So remember, you're going to have to pay $100 for the first 3 nights. So $300 is already out of your pocket. Plus, you're going to pay $90 for the next 3, or however many you stay beyond 3. So that would be like X minus 3. And then again, I told you up top, normally we would simplify this. So 100 times 3 is 300. If I distribute the 90 in, that's 90x. That's negative 270. So essentially here, 300 minus 270 is 30. So I'm going to have 90x plus 30. So this is the function that I would put in right here. And again, if I was going to stay 4 nights and I wanted to know how much it would cost, I would just put a 4 in here and it would calculate my stay. All right, last one on there is if we stay more than 6. So if we stay 7 or greater, or again, we could say, oh, not X is greater than 7, greater than 6. Again, you're still going to have to pay $100 for the first 3 nights. Now you're going to have to pay $90 for the next 3 nights. And then any night beyond that, you get to pay $80. So when we say the rest of them, we do X minus. We've already accounted for 6 nights. So we do X minus 6. So this is going to be 300 plus 270 plus, we distribute that in, 80x minus 480. And when we simplify all the way down, then we're able to figure out what that would be. Let me add that really quick. So we've got 300, right, plus 270, 570, and then we're going to subtract the 480, and we end up with 90 there. So this is going to be 80x minus 90. And this right there would represent our piecewise function. Okay, so just recognize you're looking for rates of change, and then we got to restrict those domains, and then just make sure that we account for, if we need to, a consistent cost that stays the same, and then the changing costs as we move up.